All right. Good morning or afternoon, everybody. It's Thursday. This is the last video you have to endure. And it's almost unfair, isn't it, that I'm putting what I'm doing every day? I feel kind of bad about it. I do. I really do. I hate being that person to rub things in. But whatever. It's happening right now while you're at school. Okay. We're going to continue from yesterday, and we're going to talk about more U substitution. And, ooh, I don't like the white background. Let's fix that. All right. So we're going to talk more about U sub, and we're going to look at a few that maybe you read about that come up where it's not just always clean and pretty. So this is just a continuation from yesterday. And the idea here, folks, is going to be that very similar, but maybe there's an extra number somewhere in the problem. So we're just going to dive right in. Let me show you this, and let's think about it before I do it. What if I gave you this problem? Of course, I lost my problem the minute I tried to start it. That's never fun. Okay, let's pretend similar to what we had the other day. Let's say it's an x here, and then x squared plus 1, and then, I don't know, squared maybe x. Okay, so here's our problem. Think about what part of this you would want to be your u, and then let's see if this works out, okay? We got an x, that's pretty simple. This is kind of a mess, so I would probably choose that to be my u. And if I choose that and I go to take my derivative, I get a 2x dx. Now, what we want to happen is we want to see our derivative sitting next to us in the problem. And we do, it's just a little different. We see an x, but when we do the u substitution, this tells us that we need to see a 2x. And if you're thinking, well, crap, we don't see a 2x, is this going to be legal to like substitute? The way I think of it is I'm like, well, yeah, it is, because I still see an x dx, and here I still see an x dx. We just have this extra 2 that we have to worry about. And when I say worry about, we don't have to worry about it. We need to kind of get rid of it. And if we get rid of it, then it's just, we'll know exactly what to plug in. So if I take this 2 and move it to the other side, it becomes a 1/2 du equals x dx. And that's actually quite awesome, because now I can replace my x dx, and instead of just plugging in a du to replace it, it's just now a 1/2 du. So when I go and make all the substitutions up here, this turns into the following. All of that is my u, so I have a u squared. My x dx is now gone and replaced with a 1/2 du. And some of you might have even thought of this before I started the problem, where you thought, well, can't we just put something in front of the integral to make this work? And we really are. This is what this is going to do, because this is just a constant, All three of these terms are times one another. So I'm going to move this constant to the front because it's just a constant multiple. And I'm really saying it's like 1/2 of the whole integral. And I hope that that makes sense, because we're working backwards here. We got the derivative to turn out to be a 2x, but if we apply this 1/2 to the front, those sort of cancel each other out. And then we integrate, so we've got, I'm going to recopy my 1/2, and this is now a u to the third over 3 plus c. From here, what was my u? Let's plug that back in. Oh my gosh, what was u? There it is. X squared plus 1. I need to make sure that I keep the cubed on it. All over 3, and then plus c. And then you can combine these. So final answer, x squared plus 1 cubed over 6 plus c. Where'd you go? There you are, c. So that's just stepping it up a notch, right? Like that's, oh my gosh, we wanted to use a u sub. It didn't look identical right here to what we wanted it to be, but that's okay. If it's just a number, just move it over and go on with your day. So Let me give you one to try and see how that goes. Let's choose a different background. Let's go with the blue-black. Ooh, that's beautiful. Okay, let's see if how you do with this one. I'm gonna actually have you do it and hit pause, right? And then come back and we'll see if we got the same thing. So let's try. Oh, there's got to be a pretty one in here somewhere. This isn't pretty, but whatever. Not as fun as I wanted it to be, but we'll go ahead and do it. Let's go with 2x minus 1 dx. Okay. Give it a try. Give it a try. Okay, so if you came back, hopefully you came back to me and you didn't just hit stop and have a party. But right here we have, if we let our u equal what's underneath the radical, because that's really the only function that you see with an x in it, then the du for this is just a 2 dx. So once again, I don't see the 2 sitting here, I don't see the 2 back here, but if I move that 2 to the front, okay, if I divide it off of both sides, now I can still replace my dx with a 1/2 du. So almost identical to the last problem. The only thing different is the function I used. So u is still 2x minus 1. And it goes underneath here, underneath the radical, and now there's a du times 1/2. So I can sneak the 1/2 in here if I like, but I like to save time, and I know it's a constant, so I'm just going to go ahead and move it to the front. And then, yeah, you've got 1/2. We're going to integrate that, and we pretty much memorized this one by now, probably. U to the 3/2 times 2/3. Let's see. And then I'm going to clean up my fraction, cancel, cancel, and I'll plug in my u. 2x minus 1 to the 3/2 all over 3 plus c. Alright, so hopefully you're feeling good about that and it's not too terrible. Once again, like yesterday, they might give you a definite integral. They might put some values here. And if they did, no biggie. Just plug them in when you're done here. Plug in the top bound minus plug in the lower bound, and then you'll have your answer for that. Alright, let's try something else. How about one more? Let's do one with trig, because those are fun. Let's try sine squared of 3x cosine of 3x dx. Whew, this is a thinker. Take a minute and look at this. If you choose a bad u, then go back and choose another u, okay? If it doesn't work for you. So take a minute or 2 or 3 and then come back. Okay, so this one, and a lot of times people try just choosing like 3x for their u and then they don't go anywhere. Or maybe you choose cosine of 3x because you know the derivative of cosine is sine. But really that squared is the indicator to me that I need to be careful, and I might want to rewrite this before I even start. So to me, I'm going to be like, oh yeah, that squared being there really does just mean this. And this is going to help me choose this one as my u because it's got some extra stuff happening to it, okay? So this is the thing I want to really get rid of. So I'm going to see if this works. Let's hope it works. If I let u equal the sine of 3x, okay, then my du would equal, well, the derivative of sine is cosine of 3x, but not quite. It's a chain rule in here, so times 3. I'll put that to the front, and then dx, okay? So if we look here, this will get replaced. The squared won't, but that's okay. It'll just be a u squared. And then I've got cosine 3x dx. All of that will get to go away and get replaced by a du. No, 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 not just a du. Move that 3 over. A 1/3 du. So I'm going to put the du here. I could put a 1/3 here, but I prefer to bring it to the front. So it's just like that. And then we go and integrate. So we've got 1/3 that I recopy, the constant multiple, times u3 over 3 plus c. Those 3's don't cancel. Just be careful. My u was really, what did I do? Sine 3x. Okay, so we've got a sine 3x here. All of that cubed over 9. And that is taking a derivative. Woohoo! No, it's not. It's taking an antiderivative, dummy. Okay, so that's what we just did. Now, do these get any worse? Well, of course they do. This is BC calculus, baby. So these get a little worse. So let's talk about one more step up where, you know, maybe it's not exactly like you want it to be, but you still wish you could use the u substitution. And I promise it's not that bad, but let me show you one more weird one. Okay. Oh, that's not a pen. Okay. Let's pretend that I gave you this. So this is actually similar to one we did a couple of moments ago. Okay. Where we didn't have the x in the front, we just had this business right here. Now, these are a little weird because you can't distribute. You see that there's a product, so you want there to be some sort of a backwards chain rule or u substitution that you can do. But if you look at this, you notice that the derivative not only isn't there next to it, but then there's this whole other variable or function, and it's like, what am I supposed to do with that crap? Well, you can still do a u substitution, okay? And you would still pick that 2x minus 1 because that is sort of the composition that's stuck underneath the square root. So that would be the smart choice. And I know that once you go to do the du, you get 2 dx. So right now, if we replace what we see here, here's what we'd be looking at. We would have the integral of, now this x, I'm just going to recopy because nothing made it go away. And then I've got this square root of u, and then I've got the dx can be replaced not with just a du, but, bring that 2 over, but with a 1/2 du. 1/2 in the front, du in the back. So this feels wrong, but it's actually quite awesome because we still did a u substitution, and the goal here would be, I wish this was a u, I wish these were both u's because that's what I'm taking an integral with respect to. But guess what, guys, there is a way to get this x out of there and replace it with a u. And the way you do that is using the same flippin' equation that you started this problem with. If u equals 2x minus 1, then what does x equal? Can you do that? Can you help me? Sure you can. If u equals 2x minus 1, then x would equal u plus 1 all over 2. I think that's right. You're just rearranging it. Just take the equation you've already used and now isolate the x. And if you isolate that x, bring the 1 over, divide off the 2, that you can then plug in right here. So your new problem is now 1/2 still in the front. I'm going to replace that x with the u plus 1 over 2 equation. I'm going to recopy the square root of u and recopy the du. This looks, in a way, worse than what we started with, but keep in mind that once you've done this, and they are the same term, we can actually distribute the square root of u into this term, and then we'll be able to do this integration piece by piece by piece. So let's be careful on this. This algebra may trip you up a little. U plus 1 over 2 is the same as u over 2 plus 1/2, right? That's all times u to the 1/2. So I haven't done any integration yet, guys. I'm just doing some algebra here. Rewrite this. Now let's distribute. Okay, so let's see if we remember how to do that algebra. I've got u to the 1/2 times u to the first over 2, okay? So if I have a u to the first times u to the 1/2, that's really u to the 3/2, and it's still over 2. You can either write it over 2. I'm going to write it as 1/2. I don't know, it just makes me feel better right now. Plus 1/2 u to the 1/2. And it made me feel better because somehow I knew in my gut that, oh my gosh, now we have a 1/2 in front of this and a 1/2 in front of this. I'm going to go ahead and pull that out to the front. So this 1/2 is going to become a 1/4. And now the stuff behind it is really pretty. Still haven't taken an integral, keep that in mind. You're going to do all this work and you're going to feel like you're finished. We haven't even begun. This is just all rewriting all kinds of substitutions so that you can now, right now, take an integral. Okay, so I'm going to come over here. Whoa, forget that work, I guess. Come over here and let's integrate. So I've got a 1/4 in the front. Okay, now u to the 3/2. I need to add 1 to that. Is that a 5/2? Yeah. And then over 5/2. So over 5/2 is the same thing as 2/5. Okay? Plus, this one we've memorized by now, u to the 3/2 over 2/3. And then plus c. So now I know I've taken my integral. I can plug my u back in. So what was my u? It was this 2x minus 1. I'm going to plug it in here. I'm going to plug it in here. I'm going to recopy all this. Okay? Whew, this is exhausting. So glad I'm snorkeling right now and not having to do this with y'all. Alright, 2x minus 1, 5/2 over 5 plus 2x minus 1, 3/2 over 3 plus c. Oh my gosh. Alright. That, I get it, it's ugly. Since both of these have a 2 in the front and a 2 in the front and a 4 down here, we feel free to reduce that. Maybe that 2's gone, that 2's gone, and that becomes a 1/2 again. We can do that. But then I don't even think I'd distribute that 1/2, and I think I'd probably leave it ugly just like that. Okay. All right. So let me give you one more of this type to try, and then the rest of the day will be yours to try problems together, okay? So let's look at, let me see if I can find a good one here. How about, okay, let me try, or let's try this one. We'll make it a definite integral just so we're getting a little bit of everything all in one problema. To the third. All right. Hit pause if you like to give it a try for about 5 minutes. It's going to take a little bit. Then come back to me and we'll see if we get the same thing. Okay, once you're back, I guess it's not going to be too terrible. It's just going to be a lot of algebra, I think. I'm going to let u be the ugliest part of this, which is right here. Let u equal x squared plus 1. And then my du would equal 2x dx. Okay? So, oh, you know what? This isn't even bad. This is a dumb problem. I was hoping it would be worse. Okay, if you finished it out, great. I'm going to stop because I'm mad at myself because I picked too easy of a problem. You should get 15/8. And if you didn't and you want to know why, go to page 301. No, 301 of your book. Man, that makes me mad. Okay, well, let me find a better one that I want it to do what I want it to do. And that's the one we're going to try. Haha. How about... I can't even find one that's doing what I want it to do. These are all working out too nicely. Find one with a quotient. gotta pause. This is stupid. Well, actually, as it turns out, everything in the book is like prettier than I want it to be, but that's okay. Until I get back, I'll find some better ones for when I get back. We'll go ahead and try one that's got a division instead of multiplication, just in case that's going to freak you out. 16 minus x to the third squared dx. Okay, so for something like this, it's the same idea. If you see multiplication or division, you look for any kind of backwards chain rule. Now, the numerator looks to be close. It's very close to the derivative of the denominator. So I'm going to choose the denominator as my u. And notice I didn't choose the squared part. I just choose, the thing that's been nested into the other function. So let u equal that, and that means my du would be, I guess, a negative 3x squared dx, okay? So based on what we did just a second ago, you want to compare this to what you see above. And I see the x squared dx, so I want to leave that alone. But this negative 3 business is nowhere here, so I'm going to go ahead and move that over. So negative 1/3 du equals x squared dx. And from here, I'm going to go ahead and sub in what I know, okay? So the x squared dx is gone, and it's been replaced with a negative 1/3 du. I'm going to put the du at the back. The negative 1/3, if you put it over here, it might confuse you. It's just a constant. Move it to the front, okay? Now, since the x squared dx is gone, my numerator is gone. That doesn't mean my fraction is gone. Please put a 1 on top. And then in the bottom, it looks like we've got a u squared. Okay, so this is what we're going to be taking the antiderivative of. Now, after doing e's and natural logs, a lot of times people look at this and they start going, oh, it's some kind of natural log. No, it's not, okay? It's only a natural log if this is a 1, okay? If I saw 1 over u right now, then I could go into my natural logs. But since it's got a real power on it, just rewrite it as u to the negative 2. And then do your normal backwards power rule. So we've got a negative 1/3 times, I'm going to add 1 to that, which makes it u to the negative 1, and then put it over negative 1. And if you put it over negative 1, that of course just makes it negative. Then we'll plug in what u was. So I've got, you know what, that's now a positive, right? A negative times a negative, so I've got a positive 1/3 times my u. And since it's u to the negative first, I'm going to stick that on the bottom with the 3. So it's just a 16 minus x cubed, and then my plus z can be out there. So that would be my final answer for this problem, okay? Y'all should have a lot of time to try problems from page 304 and 305, and we've done enough that you can do anything from these 2 pages. So I would avoid any problems that talk about slope fields because, well, I'm saving that till later. So if you see the word slope fields, then you might be like, what? Just skip that, okay? But anything like 1 through, wow, we can do a lot of these. Anything 1 through 82, maybe except for 39 to 42. Anything in here you can do now. And what I want you to do with the time left, and I don't know how much time you have left. I'm assuming it's close to an hour. I want you to pick 15. Your assignment is to pick any 15. Now, don't pick the same ones you did last night because that would make me a little angry. Except for the ones last night, pick a new 15 from any section and give those a try. And if you feel like you need more practice, pick more. If you feel like you need less practice, pick 15. Ha ha. Alright, so I love you guys. I hope you're not mad at me for rubbing in all my greatness of my vacation each day. If you're mad at me, okay, that's understandable. But keep in mind that I made these videos for you. Yeah, does that earn me any credit at all? I hope so. Y'all have a great rest of the week. Have a great homecoming tomorrow. I know there's a lot going on. I do wish I was there. There's a lot of special stuff going on, and I know y'all are going to behave appropriately at the appropriate times and make good choices and just enjoy the day. It's going to be probably one like never experienced before. So I'm with you in spirit, and we'll see y'all on Monday.